Thank you. Okay, all right. Well, we're going to look at some nonlinear equations, although I admit that's something we have seen in the past. But one thing to note is that nonlinear differential equations do not possess superposability. In other words, you can't take a solution and add it to another solution and say therefore that sum will also be a solution. Well, I'm going to show you an example that shows that it doesn't work. So if we verified that y1 equals 1 and y2 equals x squared are both solutions of y double prime equals a half y prime squared, see, that's what makes it nonlinear, this squared derivative. But the linear combination y equals c1 y1, in other words c1 times 1, plus c2 times x squared, c2 y2, is not a solution. So first of all, since y1 prime equals y1 double prime, which equals 0, in other words, take one or two derivatives of this, you're going to get 0. And certainly y1 is a solution because you're going to get 0 on this side and 0 on this side. Duh. But if y2 is x squared, y2 double prime is 2, and y2 prime is 2x. So substituting, we get x squared times 2, that's into the original equation, x squared times 2, see, equals a half times y prime, which is 2x squared. And so on the left side we got 2x squared, on the right side we have 2x squared, so y equals x squared is the solution. Now, y equals c1 times x plus c2 times x squared, in other words c1 x1 or c1 y1 plus c2 y2, is not a solution because the second derivative of this is just 2c2, and the first derivative of this, of course the derivative of c1 0, so just going to be 2c2x. And if we plug that into our equation, it becomes y double prime equals 1/2 of y prime squared. And if you check on this side, we're going to have a term with a c1 times 2c2 in it. That term is not going to appear on the right side at all. Yeah, so therefore, now that we know this, we can say for sure that they don't possess solutions to a nonlinear differential equation, do not possess the property of superposability.